So it is my distinct honor and privilege to welcome our speaker today, Professor Prof. Singh, and to give a small illustration of his career. His journey started with Bachelor's of Physics at University of Allahabad, and I'm not going to mention the year because it was long back, so you can all imagine. And then it was in Masters of Science from there, and then he went on to do his PhD from Jawaharlal Nehru University. And his career started with this very small stint at IIT Delhi, and then at the Organic and Physical Chemistry Lab at IIC Bangalore. And after that, he went on to the University of Hyderabad to work with Professor G.S. Agarwal before taking the biggest turn of his life, which I think is PRL, in 1995. Over 3 decades he has spent at PRL, and he has become one of the cornerstone and set up the Quantum Science and Technology Laboratory here. His research area will obviously be covering in the talk. I ask you to welcome with me Professor R.P. Singh on the stage.
Thank you, Sai.
Thank you so much, Professor, for taking time out. So, I'm going to give you a situation in the beginning only, because this is what we start with. Imagine you're in an elevator. Everyone has been stuck in an elevator once or twice in their life, right? But in this scenario, what we have is you're stuck with a 10-year-old, a 20-year-old, and a 30-year-old. And apparently the lift is not moving. And they ask you, can you explain what you do in brief so that all 10 and 20 and 30-year-old can understand it?
Very difficult. Because I do so many things, I don't know what to speak on. Yeah, of course, I work with light, but it's not. We work with light. We work with darkness also. You'll be surprised. If you introduce darkness in the light, it requires very special properties. So that also we study. It's not just light. Yeah. So we study light, its properties, quantum, classical, all sorts of properties, and what are their applications. Whether we can make some products which could be useful to general public. That's what we are aiming for, using that science what we do.
To expand on that, you said that some of the applications are to be in public and all. Can you mention one such application that you think we might have all used or somehow seen somewhere?
Yeah, you can say optical scanners being used now, using optical vertices. That's what I was talking of. When you introduce darkness in the light, we call this kind of structures optical vertices. I think you might have seen whirlpools, water whirlpools. So in whirlpool you will see at the center water is absent. So similar structures we make in light whirlpools. So light becomes absent at the center. We call light whirlpools or optical vertices. And these optical vertices are being used as optical spanners, and it's being used in macro machining, and there are other applications also for optical spanners. For twisting the molecules, finding the strength of the molecules, how we can break the molecule, all those things we are studying using optical spanners. This is one, and another, when I said quantum, in quantum domain we are studying quantum communication, and using quantum communication you can make very secure keys, okay? And if your keys are very secure, the message which you encrypt with keys, that also becomes very secure. So we make keys, very secure keys with the quantum mechanical principles, and we encrypt messages with that, so that it becomes very secure. Nobody can hack that. Even quantum computers, if you are having quantum computers, you can't hack those messages because they are secured by quantum keys. So that's what we do. So these are some of the applications, and there are many other applications coming in. So we can talk more about that.
I mean, given the crowd today, I think it would be quite feasible to say, I think if we go back in time before we further talk about your research work that we're going to explore now, what was your childhood like? I mean, growing up, if you try to remember what was the days like, what kind of daydreams did you have, and what were the inklings that you had that you ended up in science in some sense?
So very long question. Anyway, so when I was a child, I was not able to speak English. ओके मैं गांव का बच्चा, मैं भी, हमारे बहुत से गांव के बच्चे हैं। ओके, तो मैं सबसे छोटा भाई था। आई वॉज यंगेस्ट ब्रदर एंड इट वॉज जॉइंट फैमिली, यू कैन इमेजिन। So around 12 to 14 kids around, I am being youngest. So always पप्पू पानी लाओ, पप्पू घंटा कहाँ है? So all those things I was doing, and of course my elder brothers, they were doing good, so I was following them. Okay, so one of my elder brothers, he was like interested in science, and he was pursuing science. So भैया जो कर रहे हैं, I just followed. That's all. ऐसा कुछ नहीं कि I was very much like thinking, I have to do science, I have to do physics. And elder brother, he was getting like appreciated by everybody, and he was doing science. He was elder. He went for high school, intermediate, then BSc, MSc. I also followed. Okay, interesting. So, but in the meantime, I tell you, when I was in BSc, I got very much interested in becoming doctor. I joined PCM. My brother went for PCM. I also went for physical history math. But in the meantime, I thought I should go become a doctor. So I thought how to do now, how to go for physics. Some people suggested you can take open university, think something open in schooling, physics. Bio you can take, then you can apply. But it was too much of hassle. I just dropped. So that's how I just continued BSc, MSc. Then not only MSc. So my brother went to GNU for doing MPhil PhD in environmental science, and again I followed my brother, elder brother. I reached there, School of Environmental Science for MPhil PhD. So that's what, it's nothing great. Like in the meantime, I had like in MSc, I got interested in like how to tell. There was a paper like one course you have to give seminar. So seminar topic I chose particle physics and Indian philosophy. Okay, so I tried to connect Indian philosophy, how particle physics is related, Satwar and all those things, how dualism and that is there, how it's connected particle physics. And you will be surprised, somehow in that time I told that I don't know whether how good it is, like this conclusion. Particle physics are there, big particle physics are there in this auditorium. So I concluded that there should be two fundamental particles and there should be one exchange. There should be some interaction between those particles. So that will complete the model of the like fundamental particle and fundamental physics, like interaction between those particles, and it may exchange particle or whatever, and two fundamental. That's what I concluded. Reading those times, this particle physics, whatever was available in the library or whatever, and in philosophy. So, but I was interested in science, and to be frank, I was interested in the sense that some subject where you can think about, not like doing just nut bolt जोड़ा या बनाते गए machine बनाते गए, something where you think about. It forces you to think something from there you go further. So that's how I followed, and then I went to GNU and did PhD. Then I did PhD in environmental science. Okay, laser light scattering by aerosols. So that time environmental science, now it's very important, climate studies and all, everybody is talking of climate change and all those things. But that time environmental science I studied, it was like you take data, then you say it's increasing, temperature is increasing, temperature is decreasing, rainfall is increasing, rainfall is decreasing. You just keep on taking data, keep on doing plot, and then you tell some story. And I could not see, at least those days, I could not see any science in it. Just some story, why it is increasing, why it is decreasing, some from that data, or some reason, some. Not very solid like physics kind of thing, why it's happening. Now it's coming in, but that time it was not that, at least in there where I was studying. So I thought there is no fun. I should go to like final Mandala, I should go to physics, fundamental physics. And then I shifted to like Professor J.S. Agrawal, who was in quantum optics. Fortunately, he took me and I was like for postdoc after a PhD in environmental science, because in environmental science also I studied laser light scattering by aerosols. So light scattering I studied, that's why he agreed, okay, you are studying light scattering, and maybe aerosols, but you are laser light scattering you have studied. And he asked some basic questions I could explain, and he took me as a postdoc. and I joined him at Hyderabad, University of Hyderabad, and then he came here as director, and I moved with him, and that is also very interesting story how I moved with him. He came as a director, he joined here, and I was in Hyderabad. Then he told somebody, asked Happy to come here, and I thought he's calling me, and other students were already there, his students, PhD students. I thought I should go. So one day I came here, I went to guest house, and I came with all my bag and bag. So guest house person was surprised with so much of bag and baggage. Somebody has come. So he called director, guest house in charge, said, guest आए हुए हैं, आपके guest हैं, and guest come with all the bag and baggage. Then he asked me, I didn't call you to come with bag and baggage. Okay, अब तो मैं आ गया, I have located my house in Hyderabad. I'm here. Okay, बोले okay, अब आ गए तो ठीक है. Today you stay in guest house. And next day I got PDF quarters. So that's how I came along with him and started my journey at PRL.
I think it's safe to say that if you need something, you really need to push for it. I mean, carry everything so that you cannot go back from that. And before we proceed further, what I find quite interesting is that you seem like a person who's very inclined towards tooling with experiments, or at least having physical things and seeing them. Does it come from anywhere, or was it something you discovered while growing up, or eventually, basically, through PhD?
Doing experiments, somehow I tried maths also, like theoretical physics. It's not like that I didn't try theoretical physics because Professor Agrawal was theoretical physics. So I tried. Somehow I thought that this experiment is more important than theory. Somehow I have a feeling. Because if you see, whole of the quantum optics, Planck's this fundamental, like we were talking of photon, this Planck's explanation of black body radiation. It's based on experimental results. There were experimental results already and nobody was able to explain. And Planck tried to explain and he could explain. And that's how this particle like photon concept came, okay? Energy wave packet, this discrete nature of light, that's it. And then there's so many things, same way like you see spectrum, okay, atomic spectroscopy. So spectrum was there already. That's why both could explain their discrete energy levels, okay, because it was not, they were not able to explain. So all these things came from experiments. So I thought the experiment is much more interesting, of course. So I shifted to experiment. And I was enjoying doing experiments. You could see what is happening there instead of doing on paper. It's much more interesting. You can see that it's happening there. Even theoreticians, when they come and see it's happening there, say it's magic. Okay. So even Professor Agrawal, when I show him the result in my lab, what he thinks of, oh, it's magic. Okay. So it's really interesting to do experiments. There you can see what's happening with your eyes.
So there is one shift that you've done from environmental science to moving on to hardcore quantum optics, which is, I know fundamentally it's all physics, but when you have to have the knowledge of working at it and at a level where you're doing research, because research means that you don't have a pre-built context so much. You're trying to push the boundaries of what is already existing. So this shift for you, what was it like, and what kind of questions, were you scared that maybe it would be difficult to catch up, or were you excited that, oh, there's another horizon to explore? What was the feeling?
Yeah, I was excited. So we used to work, like I used to work very hard with Professor Agrawal trying to catch up whatever problems he used to give. And he was a very tough taskmaster. We'll give you problem, then next day we'll ask what you have done. So sometimes I will not be able to make much progress, then I will say, what I will say to Professor Agrawal. So there is not much progress. So he is very tough taskmaster, so that's how he pushed me to do something and pushed me to learn new things. And at the same time, he was knowing that I inclined towards experiments, so he will be asking me to do some experiments going outside if it is not there. He sent me to Kolkata and some other places also to do experiments. So he was knowing that I am inclined towards experiments, and at the same time he was giving me theoretical problems also. So that's how it becomes like easier having such a like tough task master. And then you have basic training, you can do it, not like that. And that's how I progressed. And it was tough. It was not easy. Yeah, you have to work very hard because we are coming from environmental science and then learning basics of quantum optics. It was not easy. Yeah.
And,
So recently the word has been in buzz a lot, right? How many of you have heard the quantum word first in a Marvel movie? Most of you? 10th, 11th? Raise your hands. Have you heard it in TV, pop culture, everywhere? Yes? Okay. So there's a very famous quote by Feynman that I'm sure that no one understands quantum mechanics. So what's your interpretation of it, and how would we have a student body from 10th, 11th and 12th? What would you take as something that can explain them the basics of quantum mechanics?
So it's really difficult. Nobody can claim that they have understood quantum mechanics completely. Okay, and there are not many things to explore still in quantum mechanics. Our basic problem is how to integrate relativity and quantum mechanics. It's really still open problem, and there are many other problems which need to be addressed in quantum mechanics. Okay, how this multi-particle system evolves quantum mechanically, that is still not very well understood. There are so many things not very well understood. People are working on, and so it's like your ingenuity, how you think, your imagination. You can come up with a problem which can lead you to very big discovery. So there are so many things you can think about this quantum mechanics. Or would you like me to say why this quantum mechanics is getting popular? You want to?
Definitely.
So nowadays we are talking of quantum 2.0, quantum revolution. Okay, it is going to change the way we compute. It's going to change the way we measure or sense the things, parameters, and it's going to change the way we communicate. Okay, so everything is going to change. How? Because it's not like that we are not studying quantum mechanics, we are not having products of quantum technology already. Transistors, they are product of quantum, electron, that's how electron movement is there, electron is quantum mechanical particle. Then laser is there, that is again photons, you see laser light. And MRI machines, they are there, again magnetic resonance, they are there. But earlier, this quantum technology products, we were having collective behavior of electrons, collective behavior of photons, collective behavior of nucleus. So all those things were there, this collective behavior, it was collective behavior. Now what's happening in quantum 2.0, the quantum revolution which we are having presently, we can address individual quantum system, individual particles, like how two particles can interact, how single particle will behave, whether we can control, we can manipulate them, how we can take advantage of this spin of a single particle. So now we can address single quantum system, single photon, single electron, one atom, two quantum dots, make them interact in a controlled way. So that's how this is. The change, that's the change from earlier quantum technology, this present. That's what we call quantum 2.0, and it has like 4 verticals: quantum computing, quantum communication, quantum sensing and metrology, and quantum materials and devices. So these 4 verticals, a lot of work is going on, and Government of India has announced National Quantum Mission and promised to invest quite a big amount, more than 6,000 crore over 8 years. And so that's what this quantum revolution. It's not only India, all over the world, USA, Europe, UK. So everywhere a lot of investment is going on. It's not only government, even big multinationals, Google, IBM, okay, you name it. Amazon, all the big companies, they are investing heavily. China is leader in quantum communication. So all the countries are investing very heavily in quantum technology now. This second quantum revolution, because it's going to change the way we compute, it's going to change the way we communicate, and it's going to change the way we sense the things, we measure the things, metrology.
So, since whenever a new technology comes in market, there's always a chance that there's going to be myths and stories around it. So, you must have heard something about quantum teleportation or similar kind of stories. Do you know anyone which is very, very far from myth, but it is propagated throughout the media?
Yeah, quantum teleportation, this Star Trek is there in movies. So you can't teleport like a human body as such. But quantum teleportation is a fact. You can teleport the state, quantum state of a particle from one place to another place. So that's what we do. Quantum teleportation we can do in the lab, okay? We can teleport like from one place, from here to there, this quantum state of particle. Okay, and here like miles apart we can do. In the lab we do for a few meters, okay, but miles apart we can do this teleportation. The quantum state of particle. As we said, they are thinking that they can, using quantum computers, they can propose new molecules, new drugs, new molecules which will be much more environment friendly as fertilizer, new drugs for diabetes, new drugs for cancer, they can propose. So these quantum computers, they can optimize like airlines, so that with less fuel you can cover more distances. Okay, what kind of network will be there, airline network, shipping companies, how they can place their ships all around the world. So you can minimize the fuel charge and less fuel expense. With less fuel and less time, you can you can do a lot of work. So those kind of things they are trying to work on using quantum computers, and so it's become a financial market, like how to optimize your investment, okay, portfolio, investment portfolio, so that you can earn more money out of given investment. So all those things are they are trying to work out using quantum computers, because it can process large amount of data very fast because of this quantum quantum principles, and that's why all the Google and Microsoft they are investing heavily, because they have lot of data, okay, and they want to monetize that data. So that's why I'm very much optimistic that quantum computer will come, maybe 5 years, 10 years, useful quantum computer, because they want to monetize that data. They have a lot of data and they want to use that data, process that data, and using that data they want to provide useful information, and so that they can have money. So it has to come, yeah. No. Although some people are very pessimistic about quantum computers, we will read all sorts of articles, but I am very optimistic that in near future, 5 to 10 years, very useful quantum computer will be there.
Since we are talking about this quantum and a lot of companies putting in money, we are talking about technology improving it all. Whenever we have seen in past like these kind of technologies that come up which are pretty important in data wise, security wise and encryption. So these are things which countries themselves want to keep under covers for their own research. But then there's another movement where we want to share our resources, where we want to do collaborative research at the global level. But then there's also a step back that we want to not give this technology to everyone. So where do you see that happening in the future 5-10 years, that would countries and companies be more open to sharing their resources, or will it be silo-based research in quantum?
They will sell the technology, but because whole like capitalism, this commercial thing, consumerism, whatever you say, everybody wants to make money, okay, and why they will disclose what kind of technology has gone into. They will give you product, you can use it, it's not like that, but they will not share the technology out. So everybody, all the countries have to work hard to develop their own technology, and they have to collaborate if they want to do like, they want to go further. Okay. So collaboration is important, but at the same time you have to develop your own technology. It's not like that they will give you field, they will not sharing. And presently itself you see USA and Europe, they are not allowing Chinese products, quantum technology products to go to their country. So they have put ban. Okay. And USA is putting ban some components like which go into the quantum technology. They are stopping that to export to China. So this is happening, and this will go on. So that's how every country has to work hard to develop their own technology. And but if you want to go further, like satellite-based quantum communication, I'm talking. So there, if you have to have global quantum communication, we have to share our ground stations, each country, which has to be global quantum communication. And so everybody has to share their resources, satellites, ground stations, which will receive the signal from satellite. So something you have to work globally, you have to work together. Some technology will be developing like your own, and you will be monetizing that. So it will go on like collaboration as well as monetization of your effort and monetization of your technology products.
The next question, like 30 years at PRI, what's the next plan? What's the next step? What do you want to do after this?
I want to contribute to the whatever technology we are in India. What we are lagging, we do research, and after certain stage we leave it. We don't go for the product thing, and then we buy everything from abroad. So that should be stopped. So if we are doing something and we can make it as a product, why to buy from abroad? So we have to work hard to develop products out of our research. That's what. And for that, if you have to collaborate with industry, collaborate with companies, then you should do that. And that's what I'm aiming for. So that whatever research is going on, if it can be it can lead to some product, useful product. So we should not stop just in the lab itself. We take it out and make that product so that everybody can use it. That's what I mean.
I mean, I know we're moving towards the end of time, and before we open it to the audience, I would also like to ask that if you had not become a scientist, what else would you have become?
Not the doctor thing, something else.
I would have been become actor or poet and writer. Because you don't believe, I am telling you, so that's why I told you I was not like science ही करना ऐसा नहीं है. After my PhD, when I was at the end of my PhD, I applied to NSD, National School of Drama. I qualified written test and I went for interview also. So, but interview somehow I didn't prepare the dialogue properly. I was not selected. They told next time be sincere and prepare dialogue properly. So, but next time I didn't go for interviews. So I am pursuing science and talking to you about this life. Same way writer also, I was when I was in JNU, most of the time you will find me in Sahitya Academy attending a literary seminar. Okay, and then science guys used to get confused. You are doing PhD in environmental science or you are doing in humanities? So I was really enjoying, and I used to write poems also. And
We need to know your favorite poet for sure.
So some short stories also I write, but it's okay, no, fine, I don't do that. I don't find time, but I would have done that, yeah, if I was not being pursuing.
I think that concludes the session for us. We are running out of time. Thank you so much, Professor, for taking time.
So I will say कि you can do anything. आप कुछ भी हो सकते हो, बस काम करते जाओ, खुश रहो.